Hello, welcome to Introduction to Java Programming. In this session, we will discuss about strings in Java. Let's discuss. What is a string? A string is a sequence of characters. So we know the char set in Java. It's actually a 16-bit char set, and any combination of those characters, is actually a string. And string usually represented in double quotes, only double quotes. No single quotes. So single quotes is actually a character, a double quotes is a string. So here as some examples like Java, ABC, 123, 0101, and any combination of allowed characters in Java language, which are specified in double quotes, is actually a string. So now how to create strings in Java? So there are two ways. One way is using string literal. So string literal is again, so anything that is represented in double quotes is a string. It's a string literal. So what is a literal? Literal is a value, right? For example, if I say 10, this is an integer literal. 3.14, this is a double literal. Right? In the same fashion, anything that we keep in double quotes is a string literal. Just by saying something like this, actually. So for example, I can write like this: string is a class, string s1 equal to, so then I say Java. So now Java is actually going to be an object. Okay, so creating strings in Java, otherwise I can say string objects in Java. Any string literal is an object. Right now, Java is actually an object. Okay, yeah. So the other mechanism is using the new keyword, we can actually create a string object. So how to create a string object using the new keyword? So let's say string s2 equal to a new string of. So we are instantiating the string class. We have string class, right? So string s2 equal to new string of. Now I can say Java, right? So here string object is going to get created. So basically there are two ways to create string objects in Java. So any string literal by default is going to be a string object, and by using string class you can instantiate a string object. Okay, and but here that there is a difference actually in the allocation. So we will discuss that allocation in detail. See, whenever you say string s1 equal to Java, so this is a string literal, right? So now this is going to get created or stored or allocated in some memory called string constant pool. Whereas when you are saying string s2 equal to new string, this is going to get created in the heap area. So now there are two memories, heap and string constant pool. These are the two memories where strings are going to get allocated. So that we will understand thoroughly now. So with illustrations, we will actually see that. Yeah, so why two kinds of allocations? What string is going to get achieved by allocating string literals in string constant pool? That what we are going to discuss now. And coming to other details, so strings are immutable. So you can't modify them. Okay, strings are immutable. So string class is defined like a final class. So public final string class, public final class string. That's how it is actually defined. It's a final class. So final class cannot be inherited, and it cannot be modified actually. Because there are so many final classes in Java, all wrapper classes. So corresponding to each data type, we have a wrapper class. Right? All wrapper classes are final classes. String is also a final class. You cannot modify it. So string is final class, immutable class. We have mutable classes also. So we have two mutable classes. One is string buffer, which is mutable. That means which can be modified. And another is string builder, which is also a mutable class. Again, why two string classes? String classes which are mutable. We have one mutable class. One immutable class. You can go for mutable classes, but you have two mutable class again. Why? String buffer is thread safe and string builder is not thread safe. Okay, that's why we have two mutable classes. Altogether, we have three classes to represent strings in Java. Okay, one is string, it's a final class, immutable, and two mutable classes, string buffer and string builder. So these are all we have to discuss now. So let's now actually discuss a few things actually, which important things. Okay, so here what I'm going to do is the first way. I'm going to create strings by using the first way, that is using string literal. Now understand how it gets stored and allocated by using string literal, how to create string object. So now let's take few examples here. What I'm doing is string s1 equal to let's say Java, and string s2 equal to, let's assume, Python. Okay, and then string s3 equal to again Java, and string s4 equal to let's say CPP. This time I'm writing C++. Okay, so how many string literals? Actually 1, 2, 3, 4. Let's now understand how many objects are going to get created for this kind of string creation. Okay, so now all objects are allocated. All objects are allocated in the heap area, right? Now let me now annotate to make you understand about this string creation and allocation. So now I have a heap memory. This is my heap memory. All objects are going to get allocated, but there is a portion of the heap that is called a string constant pool. Let's say this is a string constant pool. This portion of the heap is actually called string constant pool. Okay, as part of the heap itself. Now what is going to happen when I say string s1 equal to Java? So this is heap area. So let me actually also write, this is heap and this is non-heap. This is also called as a non-heap. This is separate memory, okay, called string constant pool for objects. Now when you say string s1 equal to Java, what is going to happen? So here the string literal Java is going to get created. The string literal Java is going to get created over here. So this is, let's say, Java. Then the string constant pool, and s1 is actually referring to this. Okay, so there is now a reference s1 referring to this actually. Okay, now when I say s2, so s2 is also going to get allocated over here. S2 is also going to get allocated over here. Yeah, that means s2 is Python. So you will have Python is available over here. Let me write this one also, and which is referred by s2. This is referred by s2, and that will be something like this. Okay, now s3. When you say string s3 equal to Java, so now what happens here? So there is again one slot that should come for Java, and there should be a reference s3, right? But this time what happens, whenever string s3, whenever this string s3 equal to Java, here, what is going to happen? So string literal object is Java, right? And Java is already present over here. Java is already present over here. So object will not get created for this line. So no object is going to get created for this particular line, right? Rather, so it has a reference s3. So now this Java is referred by both the reference variables. So s3 and s1 both are referring over here, right? So like that, JVM allocates or JVM creates objects for strings. What JVM will do, whenever you have a string literal, it actually looks at string constant pool. If already that object is available, it will not create, just it returns the reference. If it is not there, then it will create actually. Now let's see for this s4 equal to CPP. So now CPP is going to come over here because CPP is not available in the string constant pool, and which has a reference that is s4. So this is s4, and s4 is actually referring to this particular slot, right? So now how many objects you have? So you have written 4 lines actually here. Out of the 4 lines, how many objects got created? Only 3 objects got created, and everything is in the string constant pool. Everything is in the string constant pool. Now, for example, you want to create one more. So let's say now I'm going to have string s5. String s5 equal to, let's say, Python. Okay. So for this line, object is going to get created. For this line, is object is going to get created? No. So no object is going to get created because Python is already available here. It's there available. and just a reference is written back, and this reference is actually be pointed by S5 actually. So now you have 5 lines of the code, but only 3 objects are getting created. So why JVM will do like this? Because in order to make memory more efficient, because we know strings are immutable, they are not going to get changed. Why to waste memory for a constant, right? Why to create again and again an object, right, when they are constants? So that's why JVM makes use of the memory very efficiently, and already a constant is available, already a literal is already available, and no other object is going to get created, just a reference. So one object can have as many references as possible. So here Java has 2 references and Python has 2 references, right? So this is how string objects are created. These are string objects are created using string literals, right? So objects are going to get stored in the string constant pool. So hope you have understood about this. So I am just removing the drawings here. Okay. So using string literal, all objects are going to get allocated in the string constant pool. If the object is already available, object is no longer going to get created. So for the given 5 statements, so I have written like this also, string s5 equal to Python. So how many objects are created in the string constant pool? How many objects will get created in the string constant pool? Only 3 objects, but 5 references. But 5 references are there, 3 objects are there. Right? So how many objects are created in the heap area here? No, nil. Okay, string constant pool, all objects, all are getting created in the string constant pool only. And heap, 0 objects. Heap 0 objects, because all are string literals only. So you have 0 objects in the heap. Now let's see actually the second mechanism. Now you'll understand the second way of creating the object. Second way of creating string objects is actually by using new keyword, right? By using new keyword. If you remember, whenever you use new keyword, always it refers to heap area, right? New keyword means always it refers to heap area. We understood actually whenever we are discussing creation of object, when you say new, it always go to heap actually. So it always refers to heap, not string constant pool, whatever the case it may be, it refers to heap area. Right now, let's see here. So listen carefully this one. So string, let's say s1 equal to a new string of string s1 equal to new string of, let's say, Sachin. String s1 equal to new string of Sachin, right? And then, yeah, let's now understand first of all this one. Later I will go to the next one. So how many objects are going to get created over here for this line? String s1 equal to new string. How many objects are going to get created? Okay, so for this line, there are 2 objects that are going to get created. There are 2 objects. Where are the 2 objects? Where are the 2 objects? So the first object will be the first object s1 equal to new. Whenever you say new, it refers to heap area. So in the heap, you have 1 object. Okay. And any string literal is also an object, right? So Sachin is a string literal. So you will have in the string constant pool, there is 1 object. So given this line, how many objects are created? 2 objects are created. One is in the heap and another is in the string constant pool. So let me now annotate and tell you the other examples as well. So here you have this heap area, and the heap area is divided into 2 parts, right? Yeah, one is the string constant pool. This is my string constant pool, and this is my heap actually. Okay. So now let's see. This is my SCP, string constant pool. Now for this one, what happens? String s1 equal to new string of such a new always refers to heap, right? So now I will have an object that is getting created over here. One object that is going to get created here, that is actually Sachin, right? Let me write this. Sachin is going to get created over here. And what is the reference? The reference is going to be s1. So always reference is to heap only. So s1 is actually referring to that. S1 is actually referring to that. Okay, that will get created first. And now it comes to the string literal. So anything that is represented in a double quotes is a string literal. That's also an object. So now what happens? That object is going to get created in the string constant pool. So in the string constant pool, you have Sachin already? No, you don't have Sachin. So now this is going to get created. The Sachin is going to get created over here. And does it have reference? No, it has no reference actually. Right? So this is one important point to be understood. Now in the next line, what I am doing is string s2 equal to new string of Virat. New string of Virat. Okay. So now here, how many objects are going to get created? Again, here two objects are going to get created, right? New string, it refers to, when you say new string, it refers to the heap area, goes to the heap area, and the object that is getting created is actually Virat, and which has a reference, that one is S2. So always S2 refers to heap actually. That means because it is starting with new, right? New, the priority is for heap only. So now here we have the S2 getting created over here. And another object is actually in the string constant pool. Another object is there in the string constant pool, and which is going to be a Virat actually, and which has no reference. So now for these two lines actually, so this line and this line, for these two lines, how many objects are created? For these two lines actually. So this is one, this is line one, and let's say this is line two. How many objects? So total you have 4 objects created, and out of the 4, 2 are in the heap and 2 are in the string constant pool. Now let me write actually one more statement. Okay, string s3 equal to new string s3 equal to new string of again Sachin. Again Sachin. For this line, how many objects are going to get created? For this line, how many objects are going to created? So only one object is going to get created. So S3, whenever S3 equal to new, whenever you say new, object is going to get created definitely in the heap. So new means it is definitely going to get created. So which object? The object is Sachin. So Sachin object is going to get created. And reference is S3. Reference is S3. So I will have S3 is also available over here. And this S3 is actually referring to this. So let me write this S3 also. Right, whenever new, an object is going to get created in the heap. Okay, it will not check for duplicates or something. So new means object has to be created. But in the string constant pools, I have to create this particular one actually. In the string constant pool, I will have this Sachin, but already it is available. So no object is going to get created. For this line, only one. Right? Because already it is literal, it's already available. JVM checks for the presence before it is creating a string constants or string literals. It is available. So no other object is going to get created. So let me write one more actually here. So I am going to write string S4 equal to new string of Virat. Now you can tell how many objects are going to get created. So here also there is only one object that is going to get created. So whenever I say new string, S4 will be here actually. So you will have one more object is getting created for Virat, and S4 is actually pointing to that. Right. So this is again a Virat. Because whenever you say new, it will going to get created. But string literal Virat is already available. So already it is available. So we will not get new object will not get created. Of course, there is no reference to this also. These two are unreferenced only. But all the objects created with the new has reference, and they are getting reference. So given 4 statements, 1, 2, 3, 4. How many objects created? 6 objects created. So 4 in heap area and 2 in non-heap area, that is string constant pool. So this is how by using new keyword we can create a string object. But at the same time, how many are getting created, we should be watching that, because whether that particular string is already available in the string constant pool or not, that we have to see. Right. So in this way, string objects are created. I think this point is also clear. So I'm just clearing all that stuff. Okay. So by using string literal, we can create objects are straight away created in string constant pool. By using new keyword also we can create, but this time what happens, string literals are going to stored in SCP, and new means it is going to the heap actually. So this particular line, the second way, so it is referring to both the memories, heap memory as and SEP. In the SEP, that literally is available, it will not get created, otherwise it is going to get created. Fine. Then let's understand strings are immutable thing. So strings are immutable because it's a final class. So let me actually explain you with a simple example here. So I have an example. So public class string demo, the main, I have a string called king. I have a string called king. So how many objects are created here? Only one object, right? So 0, 1, only one object. And where this is going to get created? In the string constant pool, right? So now here, what is happening? String dot concat. So in the string, we have a method called concat. So what concat means? It appends. Concatenation means append at the end. Appending at the end, actually. Right? So string dot concat. String is king, and concat will actually append at the end. So now new more string is going to get created, new string. So that is nothing but king holy. Okay. So this string is going to get created. But what I'm doing is system.out.println string. I'm asking for the string actually. So what is the output here? What is the output? Okay, string str equal to king. Then I'm adding something to that string and I'm printing string. Right? What is your expectation? What is the output? Let's see actually. Let's compile this and see. So now to compile Java C string demo.java. Yeah. So it's taking some time to compile. Yeah, let me. Yeah, it's compiled actually. There's no issue. Then string demo. Yeah, so let me run actually Java space string demo. Now see the output. The output is only king actually. So what is the output here? The output is just king. So it's not King Kohli. It's just king because strings are immutable. Strings are immutable. What would have happened here? So let me tell you actually here. Internally, what is going to happen? Let me annotate and tell you. So here I have my heap memory. I have my heap, and of course I will have my string constant pool also, right? So let me actually make up string constant pool over here. Okay, when I say string king, actually, so I will have in the string constant pool only this object is getting created. So I will go over here and I will have this particular king is actually going to get created. And what is the reference? Reference is actually str. So reference is pointing to this one. So string and pointing to king actually. Now what happens? String dot concat. So string is king and concatenation is about Kohli. So you will have a new string king Kohli, but this will not get replaced because these are constants. So a new string is going to get created. So that is actually king Kohli. Okay, so now like this it will happen, but it has no reference, right? I'm not assigning it to anything. The string is not getting modified because they are immutable. See, my str is not getting modified. That is immutable. Rather, a new string object will get created and which has no reference. But I'm asking system.out.println str. So str refers to king only. So this is what immutableness. So this is what immutableness. Hope you have understood. Yeah. So now let me actually show you the output. What happened whenever I ran this, king only coming up because str is king. New string got created that is there in the string constant pool, but my reference is to king only. That doesn't change, right? That has not changed, right? So that's what immutableness. Strings are immutable. That's why you are getting by this. So by this we can say strings are immutable. Like that we can say. Now, what I want to do is, so I would like to have some mutable thing. I would like to have some mutable thing. So what I'm going to do now, there are two classes, right? String buffer is there. So now string buffer SB equal to new string buffer. String buffer SB equal to new string buffer. Now I am going to create a string buffer of Sachin. Okay, string buffer SB equal to new string buffer of Sachin. That's what I'm going to do it. Now see what I'm doing. SB dot append. So in the string buffer we have append method. So It's not actually concat method, but we have append method. So what we are doing, we are saying Tendulkar, sb.append Tendulkar. Right now, let's print actually system.out.println sb. So what is the output that you are expecting over here? So here for string, it is immutable. You are seeing only king, but string buffer is going to be mutable, right? It's going to be a mutable thing. So that means it could be modified. So what is the output? So we have to see Sachin Tendulkar. So that reference, the SB value, which is having a Sachin, now getting modified and becoming Tendulkar. Let's see by compiling this. Okay, let me compile this. So Control L, then say Java C string demo.java. Yeah, so mutability means not modifiable. Mutability means modifiable. Immutable means not modifiable. Let me run this. Now you can see. So SB is actually, when I print SB, it is printing me Sachin Tendulkar. Because it is mutable, it is getting changed. Whereas string is actually immutable, that's why it is not getting changed. So that's the difference actually. Now we have string builder also. Let me actually write the string builder one. String builder. Now let's say SB1 equal to new string builder. New string builder. Okay. Now let's have another name. Let's say Saurav. And now what I'm doing is sb1.append. sb1.append. Now I am going to append with Ganguly. Okay. So now I am going to print SB1. So what will be the output? So output will be Saurav Ganguly by default, right? It should be compulsory Saurav Ganguly because string builder is also mutable. Let me show you now this. Java C string demo.java. So string builder and string buffer both are mutable. They are modifiable. Now let's see. I can see the output as Saurav Ganguly. But king string is, it is a string. It's actually immutable. So total we have 3 string classes. String, it's a immutable, string buffer and string builder both are mutable actually. Now we have seen the example, right? They are getting changed. And what is the difference between both of these things? String buffer has come early. So it's a more legacy class, very old class actually. It's actually a thread safe. It's actually thread safe. What is thread safety? We'll understand in multi-threading. So whenever multiple threads are acting on this one, they will follow some order. Okay, so this is string builder is not thread safe. Not thread safe. So here, whenever you speak of thread safety, there is actually one modifier that is coming up actually, synchronized. Okay, so all the thread safety achieved because you have synchronized methods in string buffer. So it is not thread safe because there is no synchronized, there are no synchronized methods in string builder actually. Okay, so that's briefly about string buffer and string builder, and finally about whatever I have given over here. So let me sum up. String is a sequence of characters. It is represented in double quotes. You can create strings in 2 ways. By using literals, they are going to get placed in string constant pool, and you can actually create it the new keyword. Then they are going to get created in heap, and string literals are again allocated in the string constant pool. And you need to understand how many objects are getting created and where, based on the values that you are using as part of the object creation. And strings are immutable, and the string buffer and string builder are mutable. Okay, so hope you have understood, and see you in the next session with the string comparison. Thank you.